Alright, so we have our PR merged that is adding memory. For the sake of recording, as we already attempt to say, Lemos is not present today, so it's just us. So he has something to do tomorrow, and he needs to wake up early. So it's just me and Marinho. And in last
Hello.
session, we added. Sorry, were you going to say something?
I'm just saying hello to the recording.
All right. So last session we were adding the notion of memory and actually not allowing you to create a register out of nowhere, right? And we added a bunch of other instructions as well. So in particular, we organized the instructions and added a PC fetch. So we have the mechanism now that it shifts the 6 instructions at once, and then once it shifts everything, it falls to 0 again, which is PC fetch, and then it refills with the instructions. So that's the mechanism as I understand right now.
That is
Most
correct.
is correct. Good. Most of the code is just formatting, I guess, because I think it was the right time to do it as the project gets bigger. It will be difficult. So now let me go to the Apple cursed thing. All right. So by the way, let's try to do later something for geeks so you can run as well because it will be good like that everybody can run the system. All right.
I
So
can, yeah, we can look into the flake and
oh, you
see
have
what
Nix
it
as well,
actually.
right? Yeah, that's true. I forgot.
Yeah, because like Nix and Geeks are pretty similar. Obviously, the syntax for defining the flake is completely different from the syntax for defining a Geeks package, which is what you usually do in these cases. But we can at least see which packages it's using, so
Mm-hmm.
that helps a lot.
So for some reason, after I do some change like that, it doesn't run. It just builds the thing after a failure. But anyway, so I just had to add this again. Okay, so what we're gonna do today? We're gonna parse. Is that what you have in mind, or do you want to do more instructions? I feel like we do very little right now, so I would be fine with adding more instructions than parsing.
Yeah, I think adding more instructions would be good. Let's see. We have the control flow instructions.
What
That's
about
what
arithmetics? Because then we can
we can
already
do.
start doing stuff, right?
We can do that. We have control flow, which we added last time. We have fetch instructions, which we added the previous time. Arithmetic and logic are the next set of
Wait, do we
instructions
have
in the
control
paper.
flow? Control flow that you call is just the jump, right?
Yeah, we have jump, we have call, and we have the conditional jumps as well, and
Wait,
the
do
return.
we? I don't recall that doing like like branch if equal things like this. I don't recall adding. Let's see.
Yeah, it's Jump Zero and Jump Plus. I think it's their names in the.
Oh right, jump jump zero. Okay. Oh yeah, I recall now. And jump plus. Okay. Don't know if I like these names though. I'm pretty sure I'm gonna forget about this next month or so.
We can change them later.
Yeah, that's fine.
The
That's not a big deal. Okay, so
important.
on the opcode, what else do we need to add here?
Let's see. Alt, push R, pop R, over, dupe, drop. I think we're missing the literal fetch instruction actually.
Okay. So, what category should we group that?
That's technically. Let's see. Yeah, the categories are a bit different from uh,
Uh, how does the
over
guy in the
drop.
paper
Oh, I see.
separate?
We have. Oh, I see. We actually have the stack manipulations. We don't have the literals, uh, the literal fetch instructions yet. the problem for arithmetic because we can't do arithmetic if we don't have literals to operate on, right?
Yeah.
Uh, we should probably do at least the literal fetch first.
Mm-hmm.
Um,
How do we call that? Data manipulation, something like this. For
data
the
fetching. Yeah, the header in the paper is called load, store, and literal fetch. So it's basically all the instructions that access memory.
guess that's it then. Okay,
Yeah,
so
and then
OP load. Oops. Need to keep remembering to do that. And can I configure the spacing? I'm not gonna waste time on that now. Store and
um,
OP. How does it call? Fetch, just
yeah,
fetch.
yeah. There's an instruction called lit, which fetches a literal, an inline literal. There's load a plus, which fetches using the address stored in the A register. There's load r plus, which fetches using the address that's in the top of the return stack. There's load a, um, which is basically the same as the load a plus, except the a plus does an increment afterwards, which
Mm-hmm.
is like uh, for fetching sequential data basically, right? Load A is just here's a thing that we want to load, and we just load the one thing. Um, and then
Ouch.
there's the store A plus, the store R plus, and store A. So there's like there's 6 load and store instructions, and there's the literal fetch as well for inline data.
Mm-hmm. Okay, so what do we plan to? I suppose that. Well, I don't know if you plan to add everything. Do you have an opinion about that?
No, if we want to do arithmetic, the only thing we really need is the literal fetch. That's it.
Mm-hmm. So
And
one
then after,
so one question here. When I used assembly, a flavor of it, right?
right.
I remember using load and store a lot, but I
Yes.
don't recall any fetch. What's the difference between the fetch and the load here?
Um, the fetch literal instruction in this architecture, what it does is, when you have immediate data, like you're adding a constant to a register or something like that.
A constant to a register. Okay.
In particular, a small constant.
Mm-hmm.
Like usually, you can just do the arithmetic operation with a small constant as an argument instead of having a separate load for the constant if it's a small enough value, right?
Mm-hmm.
Um, because this is a very simple architecture, and because we are in particular because we are doing the instruction packing thing, that's not really an option. So we have a dedicated instruction to fetch an inline literal, basically. That's what the fetch does.
Okay. Sorry, I just had to reply message. Okay, I got it. All right. So I think just these three, right, and then we can increment on it as needed later.
Yeah.
So.
We just need, yeah, if we want to do arithmetic today, we just need the fetch, and that's enough just to grab the number constants for
Uh huh.
the calculations. And then the actual arithmetic and logic instructions are there's not, which is bitwise not, there's
Oh,
and, there's XOR,
right. So
and then there's
one thing here, just one thing real quick. So I remember discussing this already. Because here's what I'm trying to think. Okay, I'm trying to think
okay.
of what are the features that we can add that will make the thing like more interactive as quick as possible. Um, and why I'm saying that, because I think it's very easy for a project like this to go for us to start doing like something very monolithic without worrying about how you interface with it, and then often it gets bad on the end. Uh,
I see.
so I'm trying to think of what we can do for us to already start using the thing as an outside thing, which is like just make it an actual VM, right? Uh,
Right, right.
so we can already start getting those issues and we can improve them quickly. So my question here right now is to print, for example, that's a kernel system call that we gotta do, right?
Right.
And that will vary depending on the implementation. So I don't think we can do those things now, like kernel system calls. I think that's too costly for us to do now. In fact,
Okay.
I don't even know how to do it. I think we're gonna have to use the normal C, uni std maybe.
Um, yeah, fourth implementations, which are related to what we're doing,
Mm-hmm.
they usually implement the system calls in either C or assembly.
Okay.
Um, we can do something similar.
Yeah, we
Uh,
can call like I think it was uni std, right? That had the system calls.
I think it was, yes.
F open. Not no, it was not F open. It was like write that you can write on a specific thing. I don't know why it's not showing here. Okay, but that's fine. Well, we could do that. I don't see a problem. But okay, let's not do it. Let's not do it now, right? So, arithmetic and what else do you think is important?
Uh,
Because like I want something with strings or something like this. Because if it's just
String.
numbers,
Yeah, for strings, the other load and store instructions are important because they allow you to. They are basically helpers to do iterated loads
mm-hmm.
and stores. So like read and write a sequence of data instead of just a single word.
Okay,
Um, that's important if you're doing string manipulation because usually you want to do, for instance, string comparison. You have to
yeah,
check each
mm-hmm.
character individually, right?
Yeah, makes sense.
Uh, so we would need to do the other load and store instructions, not just the literal fetch. If we only care about arithmetic, the literal fetch is all we need. But if we want to do string manipulation, we need the other ones as well.
Mm-hmm.
So the
So let's just
instructions
start.
are
Let's just start with this. Just bear that in mind. So let's just do here arithmetic, and we're gonna do what? And
right. So the arithmetic instructions are not and XOR.
right.
That's for the logic part, and then for the actual numeric part, we have plus. Um, we have two star, which is shift left, and we
Wait,
have
wait, wait,
two
wait, wait.
slash, which is the shift right. It's basically multiply and divide by two, right?
So wait. The numeric part add normally.
Yeah.
But
So you have plus, which is what it's called in the paper, but you can call it add.
how does
We
it call in the
have
paper?
it's just called plus. So,
Oh, plus
that's
instead of add plus.
it's called plus instead. Yes. Um, that's because this is
That's
an architecture inspired by Forth. Usually, you just have the addition named the plus sign. So
mm-hmm.
that's what the paper uses.
Okay.
And then we have multiply by
Minus.
two and divide by two, which are basically bit shifts to the left and right, respectively.
So what? How should I name that? Shift, bit shift, or multiply? Should I call it that?
You can call it, I guess you can call it double and half, I guess.
Double and half. Okay.
And then there's the a plus star operator, which is it's called the multiply step. It's basically used to implement. It's a helper to implement multiplication
Uh huh.
because there
So you
isn't a
can add multiple
dedicated.
times and probably division as well, right? Integer division. You can subtract
Uh,
multiple times.
Actually, Integer division is implemented as a library in this particular architecture.
Okay.
So is multiplication actually, which is why we have the multiply step instruction because it
Just one thing,
allows us
like the
to.
fact that we don't have a minus is because we already have the plus and then just the sign that changes, right? I suppose it's that. So
Um, we have, yes, actually, that's it. And to do subtraction, the paper actually gives an example. It calls not, then it pushes a one, and then it adds
okay.
twice.
Mm-hmm. Let's see. Okay. So let's just go with this now. Then, all right. So now let's extend this. So one thing that I wanted to do, and I think we should start doing it now, is break this and start making functions instead of doing this. Um, so let's do that.
Yeah, the big if, else if, it does
Yeah.
bother me as well.
Yeah. I mean, I don't see a way. I mean, especially. Oh, right. Now we know how to get rid of the pointer, the void star. Yeah, like instead of doing this equals to, you see?
Yeah, we can do. I think it's integer value, right? The name of the method.
But I will avoid messing up with this right now, and let's focus on writing the thing, and then we just go back there and refactor.
Okay.
So let me add one here, and thank you for doing something that I didn't want you to do. Else if we're gonna add something, there we go. So let's just write the condition to match this. So we're gonna do what first?
Um,
The fetch,
let's do
right?
the fetch first. Yes.
And then we're gonna write where. Uh, should I make a new file for that?
Um, yes, as long as we can access the values from the stack and registers, we can put it in another file if you want. That's not a problem.
Let's see. How do I call that? Instructions, maybe. Oops, header. And let's write a normal header. So, um, yeah. So let's just put the functions plainly here. So what's the first we're gonna do? So what's the output we're expecting here?
The output, right. So the fetch, what it does is it looks at the program counter, which should be pointing at the next word. It fetches the value that the program counter is pointing to because it's an inline literal and not actual code.
Okay.
And then the value goes to the data stack, obviously. And then it increments the program counter because we already fetched the literal.
Mm-hmm.
So the following instructions will now use the next word instead.
Okay. So let me see. To me, it seems that we need to pass then the registers, of course.
Uh,
Yeah. So okay, let's see. So fetch like this. Let's put with that convention, I guess. So what we need to pass from here? Can you say it again? The stacks we're gonna use.
we need the stack, we need the registers.
Oh, okay. I'll just pass like this, and then we see the registers. Where's the
The data stack and the return stack.
data stack? The return stack is over there. So let me pass the data first. Okay. So let's do this one here. Man, this file is crazy. I think it's not identifying this file exists to begin with. Anyway, what's the type of these registers? Awesome.
Registers is a map table, right?
Oh, don't we
And then
need this as
oh,
well?
we need the RAM. Yeah, we need the RAM as well because we're going to read from it. Yeah, I
Mm-hmm.
forgot.
RAM. This and well, this will have to be a pointer.
I'm pretty sure they all have to be
Pointers.
pointers, right?
Yeah.
Especially the memory. We don't want to pass the entire RAM by value. That would be madness.
Why not? I don't see a problem.
Um,
Okay. So sort of like this. Man, why is it not showing the thing here? That's so weird. Anyway. So
I
new
think you
file.
have to.
So let's call instructions. I hope it doesn't. Yeah, okay. So it just imports the foundation. Nice. Okay, so include headers. By the way, I know this folder is kind of cringe, but well, it is what we have for now.
It is what it is.
It is what it is. Let's just hope it doesn't stay
Uh,
like that. Oh,
that
here.
we need. Yeah, you need to complete the include, and you need to add the return type, which should be void, I guess.
And yes, indeed. I think we just need
Oh,
opcode and maybe. Oh, we.
oh, I think you have to import the foundation as well, right?
Yeah. Import foundation slash foundation.h. And then we also need the stack. Let me just see here. The VM. Man, my mouse is weird today. Yeah. Okay, so that's it. And then here we just import
Void
that.
star, not void. That's okay.
Oh, just void, right? I guess.
Yeah, because we just want to update the state of the VM. We are not actually returning anything.
Okay, so can you describe again what we need to do?
Um,
Sorry for
right.
the noise.
We have to look at the register, specifically at the program counter, the PC.
Let me put it side to side. Can I do it? Man, there must be a way. There's no way. Aha. Okay.
There we go.
So I
There we
become a
go.
pro Xcode developer. No, I'm not. Okay, so we need to pick the register. Oh, we need to return this, I guess. What?
That's not right. We just have to call it,
Oh,
actually.
right. Yeah, the return is just yeah, never mind. The return would quit the thing, right? All completely.
It would, yeah.
So import headers instructions.h. Okay, now I can see it. All right, so
And
what do we do with this? So we get in the registers, the PC, I suppose.
yes, the PC.
So let me see here. I may base myself because I ended up forgetting how we do this kind of stuff.
Yeah, it's object
Object
for
for
key.
key. And then here we pass the string PC.
And then we have to grab the integer value of that.
Right, quite so. So, um, it was this, right? It's over there. I should be looking. Okay. And then should it be a U integer?
It should
Unsigned?
because we're interpreting it as a memory address. So yes, it should be
Right.
a U integer.
Okay. So it's a long as well, right? So it's 64. And what do I call this? Value of PC, like we do everywhere.
I guess. I guess that works.
All right. So what else?
Right. So then we have to grab the value from the RAM at the value of PC.
Right.
So
So
whatever PC is currently pointing to, that's the value we want to fetch.
right. So this would be just RAM and then object and index, I suppose. And then we just pass value of PC because it's already. Oh, but this is not. Yeah, an index. That's fine. So and then what we do with this?
We push it into the data stack.
By the way, what should I expect out of the return of this? An ID, I suppose, right? I void. I don't know what it is.
We don't particularly care what it is. Ultimately, it will be interpreted as an integer somewhere else.
Mm-hmm.
Um, so if you want to be pedantic, we can cast it to an integer and then cast it back to an ID so we can push into the data stack. But that's,
Ah
oh,
man, that
actually, I think we
the
do need
problem
to
is
do that because the data stack is a custom data structure, right?
so.
That's one of the things we changed.
I mean, it doesn't make a difference for us to handle with the setting an object because all the other stacks they also handle as pointers,
Right.
which kind of makes me think if we're adding a pointer, we might have a problem because that means that you can still get the same memory address and do some weird stuff with it, right? So
Yeah, we should probably just use integer value everywhere, basically, is what
yeah, I think
it
so.
boils down to.
Okay, but this doesn't need to be a u integer, right? It's just an integer.
It's just an integer, yes.
Okay, and then what we do with that?
We pushed the value to the data stack.
And then, ah man, it's kind of pointless because we're gonna have to do this here. The data stack requires a. Oh, but we want to eliminate the pointer, right? So, okay. Not sure if that does it, but we have to do pass it as a pointer again. Okay, so what now?
Now we have to increment the program counter.
So value of PC plus 1.
Yes, and we have to set the value in the registers map um,
So I think,
to that,
oops.
basically.
So I think it was registers set,
Set object for key.
yeah, set object, and it is value of PC plus 1 for the key PC. Okay, and I think that's it, right?
Um, that should be it.
Sorry, sleepy. Okay, so what about you? What are you complaining? Right, we forgot the
We
RAM.
need to add the RAM, yeah.
So we didn't even use the return stack.
We didn't actually.
So
Uh,
let's get it out of here. There we go. Okay, so what is wrong here? Okay, wait a minute. Okay, anything else?
uh, grab the PC, fetch the value it points to, increment it. No, that's it. That's just it.
Let me copy paste this because they're gonna do this a lot. So PC fetch. Now the next. Should we do load? And we can't, right now.
Which one?
Ah, no, never mind. We can't.
Load,
Yeah, load and store.
load and store. I mean, I guess we can do that.
Let's do the end and the rest first. I'll just put like anything here. So load and store just so they stay grouped. But then let's focus on the arithmetics. So and or not. And then we do the XOR. Am I forgetting anything? Oh, the number. But
uh,
for the logicals,
actually,
logical ones, I think it's it.
actually, there's no war in the instruction set.
Oh, there is the add and the rest, right?
Yeah, it's not and XOR plus double half and plus star.
Okay. Ah man, I'm sorry. I'm very sleepy.
It's fine. I think everyone is kind of sleepy at this time,
Yes.
me included actually.
So let's just try to do this and call it a day then.
All right.
So not. Although these I think are pretty easy, right? They don't seem hard.
Yeah, um, they all just grab values from the top of the data stack, perform an operation on them, and then push the results back.
Mm-hmm.
It's pretty
Uh,
straightforward.
they push back to the data stack or the return
Yeah,
stack.
to the data stack, to the data stack. The return stack is strictly for the return addresses, so it's used mostly for control flow.
All right. Okay. So let's do the end first. So registers, data stack, and RAM. I think we have all we need.
Actually, these instructions they don't go into RAM at all.
Oh, makes sense. They're just processing something. It's not like you
Yes.
need to load. Yeah.
Um,
So get rid of you. So we still need to go to PC, right? To get the integer.
no, actually, we just grab it from the data stack.
All right, it's
Uh,
operating. Oh man, you just said it and I am going crazy. Sorry.
And also, I think of these instructions, the only one that needs the registers is plus star, if I remember right,
So in this case, we
because
should pop, right?
yeah, we have
Always
to pop.
or peak. No, it's pop, right? We want to replace it.
We want to replace it. Yes, it's a pop.
Right. And what should be the return type of this?
Uh, well, we're going to operate on these values as integers,
So ID.
basically.
Uh,
Um,
Essentially that then, I guess.
I guess. Um, we should probably name that something else because we're going to use two values from the stack. So
Okay. So what should be the value? The
I
next
would
one,
go
right?
with A and I would
Value.
go with A and B, but that's just me. It's probably I don't know.
So this, I guess, right?
Yes, exactly.
And then we push.
Value one and value two.
But here's the thing: do I need to pass that as a pointer? Both are pointers, right? So let me see here. It's Objective C.
Yeah,
What
pick
happens?
and pop and
Right.
push. No, not push actually, because push returns void, but pick and pop they return pointer. Yes.
So I don't think that is the issue, but uh, do we have auto? I think we do. Okay, so we cannot use this.
I think it's complaining because we can't do logic on pointers, I guess. We
Yeah.
have to cast it to an integer.
That's terrible. Because to cast it to an integer on the data stack, like it's kind of dangerous because we need it's a void, right? But we should in theory store the same kind there. Otherwise, when we cast, we might get something weird, right?
That's just the thing though. For the data stack, uh, this is a VM, right? It's a pretty low level VM, so all the values are assumed to be integers, like by default, basically.
Mm-hmm. Okay, so we don't have a problem then we're just putting oh, if I can type correctly. Just doing this then.
We don't. We really don't.
So let me ah, man, I think the worst part to using Xcode are the key bindings. By far.
No Emacs on this machine.
I do, but well, I'll not have the completion there, right? Not that I think it matters, to be honest. Let me use Emacs. I gave up. Okay, so here, right. So we are writing. So we're writing here. Okay, it tries to edit, but it fails miserably. I mean, I'll disable the thing later. I'll just keep going
That's
here. So
that's a
okay,
bit sad.
now we can do it. We just need to cast it back to. Oh, we don't need this. Right?
Yeah, that seems right.
So all the
That
others
seems
they will be
correct.
the same, right? I guess.
They will be mostly the same.
Just the
The only
mouse
one
that is the weird one. Just Lunary here, and I don't know why the indentation keeps getting wrecked. Okay,
Yeah,
so
or
instead
is basically the same thing. You just replace the operation. Not takes one value and does integer like, bitwise not actually. So it would be exclamation point value, I guess, if I remember right.
this I never use this, man.
No, not it's not a literal point. It's just exclamation mark and then value. That's bitwise negation, if I recall correctly.
Wait, what is it complaining here?
Oh, it's missing the close parens on the parameters over there for some reason.
What? This is
Line
causing.
19, we're missing the close parens and open
Oh,
curly
here.
brace.
Yeah, I think I just miscopied. Okay, probably here too. What? Oh man, this got very, and it's also like in the yeah.
The curly braces, yeah.
Okay, So just this.
Oh,
And do you need a dot here? You said a dot something.
no, it's exclamation mark value. That's it.
Okay. I never use that. Like, I mean, to thinking of integers, right? That's the problem.
Yeah.
Okay, so this is the XOR.
I
How is the XOR here?
I don't remember actually. I think it might be the circumflex, but I could be wrong. Let me double check.
Bitwise operations in C++. Yes, it is circumflex.
Oh, I was actually right. I did not expect that.
Yeah, that's a
Okay.
circumflex. Let me copy. I'll copy because it's hard to type on my keyboard. Oh no, it's not actually. Yeah, it is not. Okay, so pretty simple.
Very simple. And then
Now we just need to add here. So, so let's do and we're gonna change the parameters in a sec. Or org
you org.
org mode. That's a subliminal message. Not and XOR. And then we don't need the ren.
We don't. We actually don't need the registers for these instructions either, so
Yeah,
you can get rid of that if you want.
less. Okay.
Yeah. And we
Add
have to
those
update
here.
the header and the implementation as well.
And how can I add? How can I remove for all of this? Let me see if I Control H. What? What did it do? Okay, I don't know. It did something.
I don't know.
I will never know. I'll just not risk it. When you are in weird land, be weird. Here. Again, void. Man, I keep typing org. Not.
It's muscle memory.
Yes, it is. Okay. There you go.
There we
Now,
go.
what else do we have here? Oh, now it's the number operations. So,
Yeah. Plus, double and half will be pretty similar to the ones we already have. Just pop two values, operate on them, push the return. That's
mm-hmm.
all there is to it.
So,
The plus star is a bit different because it's doing multiplication, right? That means the return value will be potentially double wide. So it actually uses the A register to store the top half of the result. So it needs to access the registers as well.
okay. So, the register was a NS map table star registers. By the way, we inherit the name with the underscore, and now we're going to go with it.
Yeah, you have
Oh,
to rename it to plus
plus
star.
star. Okay, so there we go. Now let me add those here. 1, 2, 3, 4.
Uh, let's see. I'm actually rereading the description of the plus star because I forgot the details about how it operates. Been a while since I actually read this paper, so
I'm impressed you
uh,
remember that much then.
oh, it's because I don't remember the particular details of this architecture in particular, but because I'm doing something very similar for Salem, which is my programming language implementation. The basic principles and the overall structure, they are fresh in my memory because it's basically the same. It's just the instructions are different, you see.
Mm-hmm.
Um, let's see. The plus star operation is unusual in that it is conditional and non-destructive.
Plus.
It
Okay.
replaces the contents of top, which is the top of the stack, with the sum of top and of the first element of DS, which is the data stack. And the paper uses DS to refer to the second element down. The top is the top element, obviously, but only if the original value of top was odd. Okay, so apparently it doesn't need the registers either. It just uses the values from the stack. Huh. Right, because it's a fourth thing. There are some fourth operations that take two values from the data stack and treat them as a single number for like
So just
extended
confirm
precision, I guess.
the double. It's not true, right? It's just one, and then we do by true.
Yeah, double, it takes one value and then we multiply it by two, which is semantically the same as doing a shift left. So you can just do
Let's do that
like
then. Shift the left. You mean is this or is it this?
that one, yeah.
Yeah, I
And
get
it's by
mistaken.
one actually, because you are shifting one digit
Oh,
over,
right.
and because it's binary, that doubles the value.
Mm-hmm. Okay,
Half is the same thing, it just
but the
shifts in the
opposite.
other
Okay.
direction. Yeah.
This.
And we
Oops.
have to get rid of the, yeah, that.
Just give me a second. Just a sec. Okay. So, okay, value, and then the last but not least, the plus star. So for this one, we also need the register you said. So ns map table registers. Okay, now you guide me because I don't know what to do here. So how
Um,
would we do that?
right, it pops one value from the data stack.
Uh huh.
It peaks at a second value. We
Okay.
just look at it. We don't actually remove it from the stack.
Okay.
Um, and then if the first value, if the value one is odd,
If the
we
value wait,
push
if the value one is void.
odd if it's an odd number.
Oh, okay.
If value one is odd, we
So not
push
even odd. Okay.
we if it's odd, we push value one plus value two. Otherwise, we just push back the value one.
Okay, so let's see. So value 1, if it's odd, we do
We do value one plus equal value two.
on the data stack.
Yeah, we can do a push directly. Yeah, we do value one plus value two. Otherwise, we just push the value one instead,
So we
as
just
it was.
ignore 2. That's why the peak, I suppose.
That's why the peak. Yes.
Okay, why the odd? No, I don't follow this.
Currently, if you combine this instruction with shift, you can do a multiplication operation.
Wow, why? And I would never think of this.
Yeah, I don't. I would have to actually look at an example further in the paper to tell you how exactly it works, but Basically, since we're adding the value only if the bottom bit is set, if it's one, right?
Oh, but just one
And
thing, like, should we, in the case that the value 1 is even, right? Uh,
yeah,
we just ignore, so that's why the peak. But is that
that-
symmetric? Like, don't we need to pop value 2 in the case that it's odd?
no, we don't because we will do this operation repeatedly in order to multiply value 1 by value 2. So we actually need to keep the value 2 for the rest of the operation.
Oh, I see. I see. Makes sense. So here's what I'm thinking then. We could do at some point more high level instructions, right? Uh,
We can, like, if you want, there's nothing stopping you from just straight
yeah,
up having a multiplication.
yeah, because I think it would make our lives easier to generate code as well. Because then you would have to loop over the a range of values that you have pushed, right? And then just do the thing in a series. I think that's worse than just doing a pushing a bunch and just multiplying. Well,
Yeah,
maybe not a
if we
bunch,
are
but
following, yeah, if we are, the only reason I actually mentioned this instruction is because we're following the paper.
uh huh.
Uh, Personally, I would prefer to go with the higher level instruction, so having a proper multiplication, division,
Yeah.
whatever. Um, we may have to rework the opcodes a little bit, like maybe make it wider so we can have um, more opcodes available.
Mm-hmm.
But that's something we can think about later
Yeah. Let's
after
just do this
we.
now, and then we think about it. That's true. We can try writing the Fibonacci, and then we go back at it and fix the rest. Okay. So, man, I think this compiles. Let's see.
It should.
It does. Okay. Well, that doesn't mean much, but it does. All
Yeah.
right.
Uh,
So what else now?
just real quick, we didn't end up using the registers for the plus star because I
We
misremembered.
didn't. Yes.
So we can get rid of that, make the helper simpler. It takes one argument.
That's true. Okay, so that's it, I guess. What is the next category of instructions? Oops, on the
We
opcodes.
could go back and implement the load and store instructions.
Oh, right, we didn't. Let me see here.
Stack manipulation we already did. And then there's no op and undefined. We need a proper no op, but that's it, I guess. We're almost done. We just need the load and store and a no op, and that's it.
So, what we need for the load here? Registers, I assume, data stack, and the RAM. Anything else?
Let's see. Yeah, we need the RAM, we need the data stack, and we need the registers.
Okay,
That's it.
so.
We don't actually need the return stack for this because we're not doing control flow.
Mhm.
Yeah, just registers, data stack, and memory.
Okay, so that seems pretty simple. Load and then store. Let's
Yeah,
see.
they would more properly be called load A and store A because they
Oh,
use
right,
the A
true.
register
Mm-hmm.
as the address.
Load A and store A. The fetch here can be generic, right?
Yeah, the fetch just fetches an inline value, so it's fine to just be called fetch.
Let's change here then as well. So load A and store A.
There are also loads A plus, which increments after loading, and store A plus, which also increments A after loading, after writing, that is.
Okay. So let's do this. I suppose they're not that much different, are they?
No, and they are pretty similar as well.
So let's just do this first and then we add that. So load A and store Okay, so what do we do here?
Let's see. We're fetching from the value pointed by the A register. So on line 13, we're getting the PC. We change that to A.
Right.
And then we read the value of A from the RAM. We just have to update the variable name there.
Okay.
We push it onto the stack, that's correct. And then we don't have to increment the program counter because we didn't use it for anything. So get rid of that. And that's basically it.
Okay, and the store is basically the opposite, right? You're just a
Yeah,
store
it's
expanding.
basically the opposite. Yeah, we read the value of A, we pop the data stack, and we write the value that we popped to the address that was in A.
Wait, with in the RAM, right?
In the RAM, yes.
Okay.
In the RAM.
So let me move here. So value, this will be pop. Wait,
Yes, we
so
pop a
all right,
value.
right, okay. So we pop this. We pick the value, right?
Yeah, we need the integer value.
And then on the registers, we don't need to do this.
We don't.
And then
And
here we
then
do in the value of a set for key. Was it that? I just
I
did it with
think
the
it's I think it's
object
set I think it's set object
set
or
object
set
is. Wait, no, what?
no, I think it's set value, I guess.
Oh, I think it's just a mistake because of the.
Oh no, it's object. No, wait.
It's set
Yeah, it's set
object.
object. Set object for key.
Yeah, for key. Well, I don't know why it's not showing, but anyway, it's this.
Oh, it's because RAM is actually a mutable array, not a value map. So the method names may be
Oh,
different.
that's true. It's a mutable
Set
array.
object at index subscript. That seems correct. That sounds like what we want.
So it will be value.
We probably have to do an at in front of it, right?
Yeah,
To turn it
probably.
into.
Pointer. Oh, then we don't need to get the value then. Just get the. Just get the void thingy. Just pass it. That's
Value
it.
of A. And that's basically it for those two instructions.
Okay.
Yes.
So we have. Then let
Right.
me commit this. We have a lot already.
Yeah, that's probably better.
I need to close this to commit. Or I can try committing from here. Ah, no. Let me just do that. So this, and this. Add arithmetic and data management instructions. Oh, yeah, instructions. Oh, I pushed the master. Oh man.
Oh, that's bad. That's bad, isn't it?
Yes. Well, it is what it is, I guess.
I guess.
Well,
Oh,
that's why I should protect stuff, right?
that's correct, actually.
Yeah.
Um,
Well, that's fine.
but I mean, I think it's fine. I'm looking over
I
the
can
commit
fix
right
it.
now.
I can fix it. We can do a branch out of this. Yes. So add arithmetic data management. Management. This word always gets me. Is that right? I think it is, right?
It is,
Management.
it is.
Okay, and then we push set the remote. and then we go master, we revert, yes, and then we push. I mean, it's still with a commit for the revert, but yes, at
That's
least.
that's not gonna work with a pull request because technically, if you open a PR with this branch, um,
Oh, the thing would already be there. Ah, yes,
yeah,
that's
the
true.
commit that's inside of it is already in master. We would have actually to do
A rebase and drop some commits.
yeah, we would have to do drop some commits from master
Rebase
actually. That
interactive.
would
I don't
probably be.
remember how I do that here. Interactively, there.
I
So
think you can do something like a reset hard. I think it's called
I think
the
it's
command.
here. Ctrl C on a commit to rebase it and all the commits above it. No, no, I don't want to do it. I want to squash. I don't want to squash. I want to drop. How do I do that? Emacs. Show me Emacs. Show me. Drop the commit at point K. There we go. I am not
Uh,
sure if, man, I'm kind of concerned of doing it, but tell Git to make it happen. Let's see. Error.
Make it so.
Done unto. Let me see this. Oops. Right. So cannot. Man, this is so. Let me close Xcode, man. Just a sec. I don't think it's gonna let me. Yes. Oh no, it did. Okay, so yeah, it's not gonna let me while it's open. So this, please go away. What was I going to do? Rebase, continue, and there we go. Fixed. Now I hope I didn't mess up stuff.
We can
Fail to
hope. We
push.
can definitely hope.
Yeah, can only hope. That's the problem. What happened? Protected branch hook declined. Okay, so since I messed up, I will just use that as a opportunity to, I understand. Delete this rule there, and then we do this.
Ah, I wonder what Lemos would say if he was here.
Shh. I mean, he will see the recording probably, but require pull request before merging and an approval. Everybody hates approvals. Okay, there we go.
Approval should be
Now,
named Chris.
okay, and I hope I didn't mess up here. No, I didn't. Okay. Emacs save the day. Because in the terminal, I think it's quirky syntax. Uh, I mean, we are here for like 1 hour and a half. Do you wanna halt? I can go back to this later if you want. Okay, so we are both tired. I don't know if it was caught, if I was recording already. But anyway, so we're both tired, so we're just gonna end here, I guess, today. And that's it. Today was very peaceful. It's quite funny that without Lemus, I feel with peace in mind because I don't have to keep thinking. I can just code, because code is not about thinking, right? That's what everybody should say.
Code is about flowing with the way of the world.
Yes. So anyway, well, jokes apart, that's it. See ya.
Yeah.